let's talk about fractions. Fractions. Students have a lot of different opinions and thoughts when they hear the word fractions. Some students get frustrated immediately because fractions are challenging. Some students may think, oh, they're easy. Why do we have to do them? Or some just don't like them. We could fill in all of these bubbles, including all the little bubbles, with our opinions about fractions. But overall, what we're going to start with is figuring out what is a fraction, understanding what a fraction is, what they do to represent different things, and what they mean. And then we're going to start using them. So a fraction is when we're identifying part out of a whole. Meaning we just want a piece of it. We don't want the whole thing, but we just want part out of the entire thing, part of the whole. So if we look at all of these pizzas, the entire circle, that's one whole thing. When we look at it, it's split into 4 pieces, and all of them are equal in size. That's super important when we're talking about fractions. Each piece has to be equal in size. So when we look at this one, we see that of the 4 total pieces, we have 1 of the pieces still there. So we have 1 out of 4 pizzas. We put the 1 above a nice little fraction bar to say that we have 1 out of 4 for a fraction of 1/4. If we look at the next pizza, this time the total is split into 1, 2, 3 pieces. So overall we have 1 piece left out of 3. So we would say this is 1/3 of the pizza. For this next one, we have 1, 2, 3, 4, 5, 6, 7, 8 total pieces to fill up the whole thing. And of that, we have 1, 2, 3 pieces, 1, 2, 3, out of the 8 total. So the fraction representing this pizza is 3/8. This last one, we have 1, 2, 3, 4 total, and we have 1, 2, 3 out of those 4. So we would say that it's 3/4. You can try the next 2 on your own. They may be a little extra challenging. When we look at this one, we have 1, 2, 3, 4, 5, 6 total pieces, and all 6 of them are still there. So we have 6 out of 6. Another way of saying this is that we have the entire thing. We have the whole pizza. We have 1 whole pizza. So 1 also represents this. If we look at the connection, 6 divided by 6 is equal to 1. They're the same, representing the same pizza, the same situation. If we check this one, we have 2 parts within that pizza, and we have 1 out of those 2 parts. So we have half of the pizza written like this. Sometimes fractions, though, aren't written as circles, they're written as a fraction bar. So they're written as 1 full length. So we want to identify what these fractions, what these images are representing. This first one, we have the entire thing filled in, meaning we have the whole bar. We have 1 whole bar, so 1 would be our representation for this. We have the whole thing. If we have 1 out of 1, if we divide that, that is equal to 1. For this next one, we have 1 shaded in, one that's not. So 1 out of the total 2 is our fraction, 1 out of 2. So we put the total pieces, or total parts, on the bottom, and then the top would be part of it, or sum of the pieces. Try C and D before I fill them in. We have one shaded piece out of the 1, 2, 3 total, so that would be 1/3. For D, we have one shaded piece out of 4 total, so it's 1 out of 4 for the fraction of 1/4. So again, in the bottom of the fraction, we're filling in a number in the bottom and in the top. The top is called the numerator. The bottom is called the denominator. These are connected. So when we're filling in the denominator, we're trying to figure out how many total pieces or parts are there. The numerator is just representing some of them. So for E, the total number would be 1, 2, 3, 4, 5, 6, 7, 8. 8 total pieces, and there is only 1 that is shaded in. So that fraction would be 1/8. You'll notice that all of these on this side are split into the same number. The lines all match, so we know all of them are out of 8. So we could put 8 in the denominator for each one, and then fill in the rest. When we look at F, we have 2 pieces, 1, 2, shaded in. And we know that it's 2 because of the fraction bar above it. That fraction bar above it helps us see that there are 2. So we can put a 2 in the numerator. We could also go through and rewrite this fraction in a different way. We've got 1 here. This is a piece as well. This can be split, and so can this. If we look at it a little bit differently, we have 1 of these pieces shaded, and now instead of it being out of 8 individual pieces, we could split it into 4 bigger pieces. And if it were out of 4, we would have just 1 of them now. So it's also 1/4. And we'll get to how that's connected. If we look at the next one, we have 3 pieces. Again, this top row is going to be helpful for us, but it's split into 3 pieces that we have. So the numerator is going to be 3 out of the full 8 pieces that it's split into. For H, this entire bar, the whole thing is split. We can kind of see one fraction that maybe be different than the denominator we see, but let's start with the denominator. We knew, if we look at the one above it, that we have 1, 2, 3, 4 pieces shaded in. It was just filled in that we couldn't see the lines anymore. So if we redraw them on top, based on how everything else is split, all of these are still equally sized pieces. So we have 4 pieces out of the total 8 for that fraction. We also have this one piece, which is the same size as that one piece, because this one is 4 and that one is 4. So they're also the same size, and we've got one of them shaded in. So it could also be written as 1 piece out of 2, meaning 1/2. 1 out of 2, 1/2. But we all would rather talk about chocolate. We're going to write the value that each chocolate bar represents. This light shaded area, that chocolate's already been eaten. The dark shaded chocolate, that's still there. This is going to be milk chocolate, because milk chocolate is the best. That's Miss Gogan's favorite chocolate, milk chocolate. Ms. Ross has this entire candy bar. You'll notice that every single square is shaded in. She has the entire thing. So let's count them. We have 1, 2, 3, 4, 5, 6, 7. And then we have 3 rows of 7, so we could say that in all we have 3 times 7, so we have 21 pieces. But Ms. Ross hasn't eaten any of them. They're all still here. So she still has 21 of 21. We could also say that she has all of the candy bar, the entire thing, the whole thing. She has the one whole candy bar, so 1 would also represent that. If we look at Mr. Mueller's, we could represent this again also in 2 different ways. The first way would be counting, just like we did for Ms. Ross, and we know that in each row there are 7 pieces. And we found out before that in all there are 21, so it's 7 out of 21. Another way we can look at this is we have 1, 2, 3 rows. 1 row is completely filled in, while the other 2 are empty. So we have 1 row out of 3 rows. So 1/3 will also represent the amount of candy that Mr. Mueller has. When you look at my candy bar, we can again look at it as individual pieces. There are 1, 2, 3, 4, 5, 6 pieces still left. And we know that in all, the 7 times 3 is 21 pieces. So that's one way to represent it. We can also look at it in terms of columns. I have 1, 2 columns left to eat out of 7 full columns. So we have 2 columns out of 7. So that's another way we could represent that fraction.